Hello friends, welcome to Tips and Tricks in Mathematics. This is for class 12 students and the topic of discussion is inverse trigonometric functions. In this video, we'll be focusing on NCERT solutions for exercise number 2. In the first problem, we need to show that 3 sine inverse x is equal to sine inverse 3x minus 4x cube. Now, how do we proceed? Such type of problems require substitution of x, but what substitution we should make? Now if we see closely 3x minus 4x cube and we put x equal to sine x or sine theta, it comes in this form. That is, we know the formula sine 3x equal to 3 sine x minus 4 sine cube x. So you should remember this formula. Then only you can get a solution. So we replace x equal to sine theta and put it here. We will get sine inverse 3 sine theta minus 4 sine cube theta. We are talking of the RHS. So this is sine 3 theta. Sine inverse sine 3 theta is 3 theta because sine inverse sine x is x. So we got RHS as 3 theta. But we have put x equal to sine theta. So theta will be sine inverse x. So we replace theta by sine inverse x. So this will become 3 sine inverse x, which is the LHS. So hence proved. Similarly, here in this problem, we need to show 3 cos inverse x equal to cos inverse 4x cube minus 3x. If we know this expression cos 3x equal to 4 cos cube x minus 3 cos x, the problem gets solved immediately. You should remember this. Put x equal to cos theta. So you get 4 cos cube theta minus 3 cos theta. We are solving only RHS right now. So this will be cos 3 theta. Cos inverse cos 3 theta is 3 theta. And since x equal to cos theta is the substitution we have made. So theta is cos inverse x. So this will be 3 cos inverse x, which is the LHS. Hence proved. Now write the function in the simplest form. Tan inverse square root 1 plus x square minus 1 divided by x, x not equal to 0. Whenever you get expression like root 1 plus x square, the best option or the best substitution will be x equal to tan theta. Why? Because we will see that how this square root of 1 plus x square gets simplified. So we put x equal to tan theta. So this will be square root of 1 plus tan square theta minus 1 by tan theta. 1 plus tan square theta is sec square theta. So this will be sec square theta. Square root of sec square theta will be sec theta. So this will become sec theta minus 1 by tan theta. We expand further. So we write sec theta as 1 over cos theta minus 1 divided by tan theta is sin theta by cos theta. On further simplification, we get tan inverse 1 minus cos theta by sin theta. Now, how do we proceed further? Now, these are some standard formulas which you should remember. For example, sin 2 theta is 2 sin theta cos theta. But we are interested in finding only sin theta. How do we get sin theta? We divide the angle by 2, all the angles. So this will be sin 2 theta by 2, 2 sin theta by 2 cos theta. Please note that you should not cancel this 2 with this 2. This is in the angle and this is a multiplying the angle. So you should not cut this. Only all angles should be divided by 2. So this is sin 2 theta by 2. This 2 will remain as it is, sin theta by 2 cos theta by 2, which is sin theta. 2 theta by 2, 2 is sin theta. So this will be 2 sin theta by 2 cos theta by 2. This is an important formula. You should remember that sin theta is 2 sin theta by 2 cos theta by 2. Similarly, this expression also is very commonly you will be using cos theta equal to 1 minus 2 sin square theta. Again we divide this by 2, all the angles by 2. So this will be 2 theta by 2 and this will be sin square theta by 2. On simplification, we will get 1 minus cos theta as 2 sin square theta by 2. This is very important. Similarly, you will see later that 1 plus cos theta is 2 cos square theta by 2. We will see that later. But right now, you should remember this formula. This is very important. 1 minus cos theta is 2 sine square theta by 2. So now we replace 1 minus cos theta by 2 sine square theta by 2 and sine theta by 2 sine theta cos theta by 2. That's what we are going to do. So we put this, 2 will get cancelled. Similarly, 1 sine theta will go in the numerator. So only 1 sine theta by 2 will remain, divided by cos theta by 2. This will be tan theta by 2 or theta by 2, which is half tan inverse. Why? Because x equal to tan theta and theta equal to tan inverse. Final solution must be in terms of x. That's what we are getting. You should not leave it here, theta by 2. That will not be correct answer. Correct answer is when you replace theta with x, which is tan inverse x. That's what you get, half tan inverse x. This is the final answer. Now write the function in the simplest form, tan inverse square root of 1 minus cos x by 1 plus cos x. We have already seen that 1 minus cos x is 2 sine square x by 2 previously in the previous problem. Similarly, we can show that 1 plus cos x is 2 cos square x by 2 through cos 2x equal to 2 cos square minus. These two are very important formulas which you must learn or you must remember. We just substitute these two formulas in this. So we replace 1 minus cos x as 2 sine square x by 2. This is 2 cos square x by 2. So 2 will get cancelled. This will become tan square x by 2. When square root is removed, it will become tan x by 2. Tan inverse tan x by 2 is x by 2. This is the final answer. Write the function in the simplest form, tan inverse cos x minus sin x cos x plus sin x. Now what we are going to do, we know that tan x minus y is equal to tan x minus tan y, 1 plus tan x tan y. We are going to write this in terms of tan x and tan y. So how do we do it? We first divide numerator and denominator both by cos x. So that's what we are doing here. So this will, on simplification, it will become 1 minus tan x by 1 plus tan x. We are trying to bring it to this form. So tan inverse 1 minus tan x by 1 plus we are multiplying 1 into tan x. Why? Because we want to bring it into the standard form, and 1 we will replace with tan pi by 4. Since tan pi by 4 is 1, we replace 1 here. So we write this 1 as tan pi by 4 minus tan x. This 1 will be retained, 1 plus. This is tan pi by 4 tan x. So it has come in tan a minus b form. So it has come in this form. So we can write this as tan inverse tan pi by 4 minus x. So tan inverse tan will go. We will be left with pi by 4 minus x, which is the final answer. Write the function in the simplest form, tan inverse x by square root of a square minus x square. Whenever you see square root of 1 plus x square, you have put x equal to tan theta previously. But whenever you see 1 minus x square, square root of 1 minus, then you can put either x equal to cos theta or x equal to sin theta. This is the standard way. And since it is here a square minus x square, we can put x equal to either a sin theta or a cos theta. This is very important. So we will put x equal to a sin theta here. So x equal to a sin theta, this will be tan inverse a sin theta divided by a square minus a sin theta the whole square. So on further simplification, we will get this as tan theta, tan inverse tan theta, which is theta. But our answer is not in theta. Our problem is in terms of a and x. So we should get back x equal to a sin theta. We have made the substitution. So theta will be sin inverse x by a. That's what, this is the final answer. Write the function in the simplest form, tan inverse 3a square x minus x cube divided by a cube minus 3x square. Here the substitution required is x equal to a tan theta, and we simplify further and get in the form 3 tan theta minus tan cube theta 1 minus 3 tan squared theta. This is very important. This is nothing but tan 3 theta. If you remember this formula, tan 3x equal to 3 tan x minus tan cube x by 1 minus 3 tan square x, then this will be tan 3 theta. You should remember this, else you will not be able to do this problem. So tan inverse tan 3 theta is 3 theta, but we have made substitution x equal to a tan theta will be x by a, theta will be tan inverse x by a, so our solution will be 3 tan inverse x by a. This is the final answer. Find the value of tan inverse 2 cos 2 sine inverse half. So first we are going to solve sine inverse half. We have to get the principal value of sine inverse half. So how do we proceed? We let y equal to sine inverse half. So sine y will be half, and sine y is sine pi by 6. Sine pi by 6 is sine 30, which is half, and y will be pi by 6. And since it is within the range of sine inverse minus pi by 2 to pi by 2, that is pi by 6 lies between these two. So pi by 6 is the principal value of sine inverse half, and now we substitute in this equation. So we just substitute here 2 into pi by 6, replace sine inverse half as pi by 6. We simplify further and get tan inverse 1, which is 1 can be written as tan pi by 4. So tan inverse tan pi by 4 is pi by 4. This is the final answer. Now in this problem we need to find tan half sine inverse 2x by 1 plus x square plus cos inverse 1 minus y square by 1 plus y square. So we solve these two expressions separately. So in the first expression we let x equal to tan theta. We are solving this part, sine inverse 2x. So we put x equal to tan theta and simplify and get this as sine inverse sine 2 theta, which is 2 theta. So this is x simplified to 2 theta with substitution x equal to tan theta. Now we simplify this cos inverse 1 minus y square by 1 plus y square. Now we put y equal to tan alpha and simply simplify, keep simplifying this and get the expression cos inverse. This is cos inverse cos square alpha minus sine square alpha. This is another important expression. This is equal to cos 2 alpha. Should remember this. These formulas you should remember. So cos inverse cos 2 alpha is 2 alpha. So this we got 2 theta. This is 2 alpha. We simplify further. So we simplify tan half as 2 theta plus 2 alpha. Tan theta plus alpha 2 will get cancelled. Now tan theta plus alpha is tan theta plus tan alpha, 1 minus tan theta tan alpha. Tan theta is x, tan alpha is y. So we substitute here, we get the expression x plus y, 1 minus xy. This is the final answer. Now we need to find the values of sine inverse sine 2 by 3. Whenever this value is there, it means it is the principal value. So how do we proceed? We first write y equal to, let y equal to sine inverse sine 2 by 3, where y lies between minus pi by 2 to pi by 2. We should get a solution y between these two only, else it will not be a viable solution. So we can write this as sine y equal to sine 2 pi by 3. So now y equal to 2 pi by 3 we got, but is it a solution? Principal value? The answer is no, this is not the principal value, because this value 2 pi by 3 which we obtained is greater than pi by 2. Principal value should be within these two, but what solution we got is lying outside pi by 2. So hence we have to look for another value. Now we know the expression sine 180 minus theta is sine theta. So 180 is pi, theta we put it as 2 pi by 3. So sine pi minus 2 pi by 3 is sine 2 pi by 3. This is 3 pi minus 2 pi or sine pi by 3. And sine 2 pi by 3 is nothing but sine y. So sine pi by 3 is sine y, y will be pi by 3. Now we see that y equal to pi by 3 is within this range, between minus pi by 2 and pi by 2. So this is the principal value of this function. This is the answer. Y equal to pi by 3 is the answer. Now let us find the principal value of tan inverse tan 3 by 4. So we start with letting y equal to this. Then tan y will be tan 3 by 4 and y equal to 3 pi by 4. But we know that the principal value or the range of this function lies tan inverse function lies between minus pi by 2 and pi by 2. But what expression we got? 3 pi by 4, which is greater than pi by 2. So hence 3 pi by 4 is not the principal value. We have to find the principal values. So we simply use the expression tan 180 minus theta equal to minus tan theta. 180 is pi, theta is 3 pi by 4. So we just write like this, minus 3 pi by 4. On simplification, this will become tan pi by 4 and this will be equal to minus tan 3 pi by 4. So on comparing with this, tan y equal to minus tan pi by 4, y will be minus pi by 4. Since y equal to minus pi by 4 lies within this range, this is the principal value, or this is the answer for tan inverse tan 3 pi by 4. Find the value of tan sine inverse 3 by 5 plus cot inverse 3 by 2. Now we let sine inverse 3 by 5 as A and cot inverse 3 by 2 as B and expand. So we will get tan A plus B and we expand tan A plus tan B 1 minus tan A tan B. Now we have to get tan A tan B and we will substitute here. How do we get tan A tan B? We already know A equal to sine inverse 3 by 5. So sine A is 3 by 5. Now we need to find tan A. How do we get tan A? We construct a right triangle. We put the angle A here and this is the right angle. And since sine A equal to 3 by 5, this side will be 3, opposite side, and hypotenuse will be 5. So the other side can be easily deduced as square root of 5 square minus 3 square, which is equal to 4. So now all the sides of a right angle triangle are known. So tan A is opposite side by hypotenuse. So tan A will be 3 by 4. That's what we got. So we got the tan A. Now we are finding tan B. We know B equal to cot inverse 3 by 2. Cot B equal to 3 by 2. So tan B is 1 over cot B, which is 2 by 3. So we got tan A and tan B. Now we are going to substitute them. Tan A equal to 3 by 4 and tan B equal to 2 by 3. We substitute and get the answer as 17 by 6. Now we need to find the value of cos inverse cos 7 pi by 6. Now this is a multi-choice question. Now you have to find which one is the correct one. So we let y equal to cos inverse cos 7 pi by 6 and we know y should lie between 0 and pi. So on simplifying this, we'll get cos y equal to cos 7 pi by 6, y equal to 7 pi by 6. But this is not the principal value because it is lying beyond pi. 7 pi by 6 is greater than pi. So it doesn't lie there. So we have to get a value of y which is between 0 and pi. So this is not the principal value. Now we know that cos 2 pi minus theta is equal to cos theta. So we put theta as 7 pi by 6. We put this as 7 pi by 6. So this will be 6 into 2 pi 12 pi minus 7 pi. This will be cos 5 pi by 6. And cos 7 pi by 6 is cos y. So cos y will be cos 5 pi by 6 or y equal to 5 by 6. Now we observe that 5 pi by 6 is between 0 and pi. So this is indeed the principal value. This is the solution. Y equal to 5 pi by 6. Hence option B is correct. In this expression, we need to find the value of sine pi by 3 minus sine inverse minus half equal to what? We already seen in our first video that sine inverse minus half, the principal value is minus pi by 6. If you don't know how to do this, I request you to please go to my uh, first video which is telling about the introduction to the inverse trigonometry function, and also to exercise number 1 where this problem is solved. So right now we are directly taking the solution. So we substitute sine inverse minus half equal to minus pi by 6 in this expression. So this will be sine pi by 3 plus pi by 6, which is equal to sine 90, which is equal to 1. So option D is correct. This is to be read as D. Now we need to find value of tan inverse root 3 minus cot inverse minus root 3. So we find principal value of tan inverse root 3 first, then we find principal value of cot inverse minus root 3. So let us do. How do we do? We let y equal to tan inverse root 3, then tan y will be root 3. Root 3 is tan 60 degrees. We know tan 60 is tan pi by 3. So y equal to pi by 3, and it lies between minus pi by 2 and pi by 2. So y equal to pi by 3 is the principal value. So we will consider tan inverse root 3 as pi by 3 value. Next we compute cot inverse minus root 3. How do we compute y equal to cot inverse minus root 3? Y should be between 0 and pi. So cot y will be minus root 3. Since cot y is minus root 3 and y belongs to 0 to pi, either it should be in first quadrant or second quadrant, and it is negative, so it must lie in the second quadrant. The solution must lie in the second quadrant. So we know that cos pi by 6 is root 3, but we have to get minus root 3. So we write cot of pi minus theta is minus cot theta. So cot of pi minus theta, we put it as pi by 6. Cot pi minus pi by 6 is minus cot pi by 6, which is minus root 3. So we replace minus root 3 with cot pi minus pi by 6, which is cot 5 pi by 6. So cot y is equal to cot 5 pi by 6. Cot y is equal to cot 5 pi. So y equal to 5 pi by 6 is the principal value, since it is lying between 0 and pi. Now we substitute the values of the two principal values computed in this expression. So we just put that pi by 3 minus 5 pi by 6, and on simplifying we get the value of this expression as minus pi by 2. Friends, with this we conclude this video. Please like and subscribe my channel so that in future more videos can be released to you instantaneously. Thank you very much, friends.